Hey guys, this is Mr. Returns. We're over here at the Mount Juliet Library, continuing our astronomy series. Now, originally I was going to go planet by planet, but I realized we've got to get some words out of the way. First word is what we call an ellipse. Imagine a perfect circle and now taking that circle and stretching a little bit. That's what we call an ellipse. For example, you see that picture over there? Red is a perfect circle. The other circles are circular, but no longer a perfect circle anymore. That's what an ellipse is. And that's important because all of the planets orbit around the sun in an elliptical orbit. All right, this is what we call eccentricity. The more eccentric it is, the more out of round it may happen to be. Another couple of words are going to be rotation. Rotation is going to be the planet spinning around on its axis. If I were a planet, I would have just completed one day. Here on planet Earth, that one rotation is going to be 23 hours, 58 minutes, or 24 hours. Revolution is going to be the planet orbiting around the sun. Remember, all the planets are held in by the gravitational pull of the sun. Because they orbit in an ellipse, that means sometimes the planets are going to be close to the sun, other times they're going to be further away from the sun. For example, perihelion means that we are closest to the sun, and in the northern hemisphere, that happens in our winter. Aphelion is when it's furthest away, and again, in the northern hemisphere, that's going to be happening in our summertime. The changing of the seasons has nothing to do with the distance between the Earth and the sun. When you look in the night sky, another key thought is that the constellations are constantly changing. For example, here's Orion, named after Orion the hunter. We don't see that in the night sky all the time. We don't see that in the summertime. These are what we call seasonal constellations. They are constantly changing, and all of these constellations all seem to revolve around a central point. That central point is the star Polaris. You find Polaris by going to the Big Dipper. The outer two most stars are called Murik and Dubhe. You line those puppies up, and that's going to point you directly to Polaris in the Little Dipper. Now, Polaris is important here on planet Earth because it happens to line up with our latitude. I'm from Long Island, and in Long Island, we take a look at Polaris at 41 degrees in the sky. That's because the latitude of Long Island is 41 degrees. In Mount Juliet, we look at that to find it 36 degrees in the sky because that's going to be our latitude for Middle Tennessee. Remember, if you take a look at this picture over here, this is a time-lapse picture, and you can see how all of the stars seem to be revolving around one central point, and that's going to be Polaris. Where are we heading next, guys? We're going to hit on each and every planet like we're doing a train tour. All aboard!